Okay, so I wanted to give you some notes on the periodic table and quickly review some things that we already know. So far, we've learned that the basic symbols, some of the important ones like hydrogen, there's H, and Al is aluminum, and S is sulfur, and so on. So we kind of learned that. And then we also learned that there's groups. So if you look at this group right here in this first column, column one, we call these alkali metals. This next group is alkali earth. These are transitions. These are other metals. These are the metalloids or semi-metals and so on. And really this little group over here, this is halogens, but they're included in the non-metals. And then this is halogens and rare earth, right? So we kind of know that already. But I want to show you something new. I think we've discussed a little bit of this thing that if you look at this number right here, that's the atomic number. There's 1, 3, and 2, and they just go in order. We just go from left to right and keep going across. And this tells us the atomic number. Just going to call it AN. And that tells us how many protons they have. And that really decides what element we have. So if we had hydrogen with one proton and we add another proton to it, then we then get helium, and it acts a little different. Okay, so that's one thing we also know. So if I ask you what the atomic number of nickel is, you just look at it and say 28. And some periodic tables are different. They move this number. It's not always on top. It might be below. But you're always looking for a number. There's no decimal because there's not a half of a proton. It's either 3 or 4 or 5. There's a whole number. Okay, so keep that in mind. So I'm going to clear this. And the next thing I want to show you is something with bonding. So we're going to do bonding, and there's ionic bonding and covalent bonding. In ionic bonding, they form ions, right? So ionic, I'm going to write this over here. You may want to have your periodic table. I don't think I said that. But you should probably have that out. Maybe even take a little bit of notes on this. There's ionic, and they form ions, and they have cations. I'm just going to say CAT, and they form anions, AN. Okay, the cations are positive ions, and the anions are negative ions, AN, and they form negatively because they add electrons, and cations form positively because they give away. Because electrons are negatively charged. If you give some away, but you become more positive. If you take them on, you become more negative. Okay, so there's ionic compounds, and then there's covalent. Okay, COV, you may say, but it's covalent, and these form when they share. Okay, and there's really some groups here that form mainly ionic, and that's going to be all your metals. So everything over to here, if they're in the compound, even these, it's ionic. They're going to form an ion. And then we have this group here. I'll do a different color. We'll go with blue. This group right here, kind of these guys right here, these form covalent, and they share. And there's certain things we need to know that can be helpful when we're trying to figure out how they bond and how many atoms of each. And that is how many electrons they have in their outer shell. And if you remember, I'm going to clear this. If you remember, there's something called a valence electron, VALENCE, valence electron. And that means the outer shell electrons. And if you remember, there's another rule called the octet rule. I'm not going to write that name down, but that means atoms want to have a full outer shell. So they attract other electrons, or they give some electrons away, so their outer shell is full. Okay, and they do that by taking them on, giving them off, or by sharing. Okay, so for bonding, the thing we're worried about is the valence electrons, because that'll tell us how they form different compounds, whether it's a molecule or an ionic compound. So valence electrons. And it'd be great if we could know what they are, right? And then we could make good predictions. Well, periodic table, it tells us what they are just by looking at it. So let's look at this. So let's see, color, go with green. So we can just remember this is, if we look, they have 18 groups, and groups go across. right? This way. So this is group 1, this is group 2, 3, 4, just fill them in, 5, they go all the way over. This is 13, this is 14, this is 18. You just fill all these in. I'd fill them in on a periodic table that you have, so you kind of get an idea. So on the periodic table, you have 18 groups. You also have something that goes down this way, and these are called periods. See if I can write this sideways. It's called the periodic table. That's where that name comes from. These are periods. And there's 7 of them. 1, 2, 3, 4, 5, 6, 7, right? And then the way to think of periods are they're rows. They go down from 1 to 7, but really they're the whole row, their whole row that goes across. So period 4 includes all the way from potassium all the way over to kryptonite. Or not kryptonite, krypton. And then groups, they go the other way. So they're columns. Group 1 goes from hydrogen all the way down to francium, and so on. So groups are labeled across, but really they are made up of columns, and periods go from top to bottom, but they're really referring to rows that go across. Okay, so that's just I wanted to show you that 7 periods, 18 groups, and then these guys right here, if you look at this 57, if we go up here, this is 56 right here. These just slide right in there. It says 57 through 71. There's 72. Look, there's 71. It just doesn't, it's not possible to fit this in and not make it super, super long. So they kind of put it underneath. Okay, so that's that. I'm going to clear this. 7 periods, 18 groups. Okay. But here's something that's really cool about the valence electron. So it'd be great if we knew what was in each, right? Well, we do just by looking at the periodic table. So we know here we have group 1. So this tells us we have 1 valence electron, just based on what the group is, right? So I'll use pink. This is 1 valence electron. This is 2. These ones we're not going to worry about right now. 3, 4, 5, 6, 7, and 8. These are called transition metals, though. The reason we don't worry about them is because we can't know them. There's multiples. So titanium has like 3 or 4 different arrangements based on what you have and how it bonds with something else. So they have to tell you these. So we don't worry about what they are. We just look for the charge that they give us, and then we're good. Okay, so we don't worry about any of these. They just tell us what they are. Which makes it much easier. So don't worry about these guys. We're really only worried about these ones. So I go back to my purple. So we have 1, 2. So this tells us 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, 8. And there's really a dividing point here. It's right here with these guys. 4 is like halfway between. So these guys tend not to form ionic compounds because they're not going to give 4 away. And it's harder to take 4 on, so they tend to not form ionic compounds because it's a lot to give away 4, take on 4. So it's a lot of work. So they tend to just form covalent. They don't form ions. So you don't see very often carbon or silicon at all. Or tin maybe. These guys are a little bit different. We'll just say these groups here. So tin maybe. Lead we can. These probably kind of fall into the unknowns as well. But these 3 mainly, they do not form ionic compounds, but these guys do. So these have 1 valence electron. So if you have 3 or less, you're going to give that away. So that just tells us if it's giving it away, if it's giving away 1, it has a charge of +1. If it's giving away 2, it has a charge of +2. It's giving away 3, +3. And this doesn't. But now we have a different situation. This has 5. It's not going to give 5 away. It's going to take on 3. So if it takes on 3, it is then going to take on 3 negatives. So its charge, I'm not going to use that color. Its charge is going to be, go with orange. minus 3 because it takes on 3 electrons. This takes on 2, so it's minus 2. This takes on 1, it's minus 1. But look at this guy, 8. It already has a full shell, so it doesn't do anything. It just stays, doesn't form with many other things. That's why they call them noble. They don't interact with many people. Okay. So that's kind of what I wanted to show you. You can look at the periodic table. You can know group 1 is plus 1, group 2 is plus 2. This group 13 is plus 3. And the numbers of the groups on your periodic table, if they're numbered, you can just use them, right? Group 1 is plus 1, group 2 is plus 2, group 13 is plus 3, 14 is different. Group 5 or 15 is going to be negative 3. Group 16 is going to need 2 more, minus 2, 7, minus 1. These we don't worry about. And this is kind of how we can use them to form or figure out the ionic compound that they're going to form. And we'll do more of this in class, but I wanted to show this to you. Make sure you take notes, add this to your periodic table. Just put a plus 1, plus 2, plus 3. Leave this one alone, minus 3, minus 2, minus 1, right? And 5, 6, 7 if you want to put that. But if you just know the group number, you know how many valence electrons are, and you know the charge. Okay, I'm going to add some questions. Go ahead and answer the questions, and you'll be done.